Alright, this is chemistry video 11.2b. This video follows up the Boyle's Law video, and this is Charles's Law. It's the second gas law that we're going to learn about. So in this video we're going to be thinking about Charles's Law in terms of kinetic theory, and then we're going to be doing some problems as well that look at changes in temperature and volume of a gas. Alright, so Charles's Law states at constant pressure, the volume of a gas is directly proportional to its Kelvin temperature. Okay, this Kelvin part is important. Does not work in Celsius. That's why we learned how to convert between the two. Okay, because it needs to be in kelvins. Okay, so directly proportional. So that means if the temperature doubles, volume doubles. Okay, they are directly proportional. This is the opposite of Boyle's law that we just learned about. Okay, and you know, in contrast, if the volume is cut in half, then the temperature is cut in half. Okay, so let's look at kind of an example. So let's say I have like a balloon. Okay, it's got gas particles in there. All right, so let's say I'm going to increase temperature. Okay, I'm going to increase temperature here. Wow, that's special. I'm going to increase. That's totally illegible. Okay, I'm going to increase temperature. So, let's think about what's happening here. Okay, so as I increase temperature, these particles are going to start moving faster and faster and faster. Okay, I've already said that according to this law, my pressure is going to remain constant. So, if I want the pressure to remain constant, even though the particles are going to be moving faster, the only way for that to occur is if my volume increases. Okay, as you increase temperature, the volume will increase, and so I still have the same particles here. Okay, but because the particles are moving faster and faster and faster, even though the volume's increasing, my pressure remains constant. So we kind of think about that going both ways. And then if I then go and decrease the temperature, okay, my volume is going to then decrease again. Okay, if my pressure remains constant. So my pressure is remaining constant. Remember, that's key. Pressure is constant. If you don't remember that, it's going to be confusing to you. Okay, so I have these particles in a balloon, and I increase the temperature, so the particles go faster and faster and faster. And normally that would increase the pressure, but the pressure is going to remain constant, so my volume is going to have to increase to keep the pressure the same. Okay, and so as I keep increasing temperature, my volume will keep increasing in order to keep the pressure constant. Okay, and if I decrease the temperature, the particles are going to slow down. But in order to keep the pressure constant, my volume will decrease. Okay, so that's what's going on in terms of the kinetic theory there. Let's look at some problems. So, just going to do one sample problem here. So a balloon is filled with 3 liters of helium, 22 degrees Celsius, 760 millimeters mercury. Okay, it's placed outside on a hot summer's day when the temperature is 31 degrees. Pressure remains constant. What will the volume of the balloon be? So a few things to keep in mind here. First of all, it's telling us the pressure remains constant. Okay, this unit right here is my pressure unit. So it's remaining constant, so basically it's extraneous information. You need to recognize that this number doesn't really matter right now because it's just going to remain constant. So it's going to start at 760, it's going to finish at 760, so don't really need to worry about it in terms of the math. Okay, you're going to be tempted to just try to do something with every number they give you. Okay, we need to figure out what numbers are meaningful and which ones are not. Okay, so that's the first thing you need to identify. Second, okay, my temperatures here, I'm going from 22 degrees, okay, to 31 degrees. But those are both in Celsius, and I already learned before that my temperatures need to be in kelvins. So the first thing, or the next thing you need to do, okay, is convert those. So remember, the Kelvin temperature is equal to the Celsius temperature plus 273. Okay, Kelvin temperature is equal to Celsius plus 273. So I need to convert both those units. Okay, so that first one, I have 22 degrees Celsius plus 273. Okay, so that's 295 kelvins. And the second one is 31 plus 273. Okay, so that's 304 kelvins. So here's basically what's happening. I have a 3-liter balloon, okay, and I'm then taking my temperatures increasing from 295 to 304. That's what's happening. So identify what's happening. I'm taking a 3-liter balloon and I'm raising the temperature from 295 kelvins to 304 kelvins. That's the situation. Now, according to Charles's law, what should happen if I have a 3-liter balloon held at constant temperature and I've raised the temperature? Well, according to Charles's law, my volume should increase. So I'm going to set this up very similar to the other problems. I have 3 liters. Okay, I'm going to start with what I'm trying to find. Okay, my temperature is going from 295 to 304. Okay, so I have to figure out which one goes on top. Well, I know that if my temperature increases, my volume should increase. So I'm going to multiply 3 by a fraction. If I want the 3 to go up, it needs to be a fraction that's greater than 1. So I need to put the 304 on top, 295 on the bottom. Okay, so now I'm multiplying by 3 by this fraction that's greater than 1, so the 3 should go up. So, on your calculator, you're going to do 3 times 304. You're going to divide that whole thing by 295. Okay, and if you do that right, you should get 3.1 liters, and that makes sense. Okay, if I have this balloon, I raise the temperature a little bit, the volume should go up a little bit. Okay, so that's your final answer. Again, there's some practice problems in the book, 12 to 16 on page 393. I think that's your next, or one of your next tasks.